Devil's Hole is one of the worst places to be a fish. It has lethally low dissolved oxygen, critically high temperatures. Nearly any fish that goes into it would die. These pupfish are always at the edge with such a small population in such a limited area.
This fish is found nowhere else in the wild or in nature.
With under 40 pupfish left in the wild, they are possibly the rarest fish on the planet. But how did they end up in such an inhospitable place? And what makes their survival so important?
People will ask, should this fish exist in such an extreme environment? And honestly, I have to ask myself, how and why? Is it a pupfish miracle? Devil's Hole is part of Death Valley National Park. Devil's Hole was actually formed by a geological fault, and so that's what opened up. And I like to call this a window into the aquifer, or the groundwater. We don't know how deep it is. Divers have been down to 436 feet and they didn't see a bottom. It becomes a true cave system below 85 feet. It's also considered an extreme environment. So that water you're looking at is 93 degrees Fahrenheit all the time. There's very low oxygen in the water. The shelf doesn't get a lot of sunlight, so that limits the amount of algae that grows. The pupfish, they originally got their name because they acted like puppies. They like chasing each other. They're curious. When we dive to count the fish, they'll come swimming up to you and say, wow, you're a big fish. How long have they been here? Geneticists have estimated between hundreds of years to tens of thousands of years. We started counting the fish actually in 1972. So we used scuba as well as surface counters to estimate the population size. Historically, the highest count is just like 540 fish. In 1966, there was the Endangered Species Preservation Act. And the first species put on that list, Devil's Hole was one of the group of fishes in 1967.
The Devil's Hole pupfish are kind of an odd conundrum because they are able to live in this really, really extreme environment, but at the same time, they're a relatively delicate fish. UNLV found that when the dissolved oxygen goes low, they actually start producing ethanol, and essentially when times get tough, the fish get a little bit drunk and it helps them to survive a complete lack of oxygen. These are extremophiles and they're living at the edges of what a fish can survive.
Devil's Hole being so deep in such a large body of water that earthquakes around the world can create these large waves. Now, they are not truly tsunamis. They're actually called seiches. Certain earthquakes, depending on the depth and the magnitude and location, typically around the Ring of Fire, so from Chile, Mexico, up to Alaska, down to Japan, and along that western part of the Pacific, large earthquakes can cause waves up over this boulder here.
This winter, Devil's Hole experienced seiches that were the result of two very poorly timed earthquakes. The effect of this was that sloshing of water back and forth washed all the algae, all the food and vertebrates, everything off of the shelf. That caused a food limitation and the fish began to suffer.
Recently, we're concerned about the population. We went from over 200 fish in September of 2024 to as few as 20 in the end of February.
We're in basically the middle of nowhere in the Mojave Desert, inside Ash Meadows National Wildlife Refuge in Amargosa Valley, Nevada, and we are approximately 1 mile away from where the actual Devil's Hole exists. The Ash Meadows Fish Conservation Facility is designed to maintain a lifeboat population of the Devil's Hole pupfish. So we tried to recreate a really bad ecosystem, essentially, in captivity. We had to figure out a way to collect fish without collecting fish. We did that by collecting eggs that were produced. Initially, we collected during the peak of summer and the dead of winter, when we knew that eggs produced during that time had an extremely low, almost 0% survival rate to adulthood.
We increased the amount and frequency of some frozen food. We targeted some benthic macroinvertebrate food, and for just macroinvertebrates.
We did actually use these fish for the first time in 10 years in their intended purpose as a lifeboat population. We stocked 43 fish over 2 different stocking events into Devil's Hole to help the population, and since then the population has largely stabilized, and we've started to see new babies, eggs being produced, and signs that the population is starting to recover.
So it's encouraging that, this lifeboat actually works.
The fish facility is really playing a big role in both providing the data and the materials to be able to continue to shepherd them to success. There's always a question of why bother? There are a few reasons that I show up for work every day. They've been doing fine in the wild for the last 10,000 years, but since human intervention and human activities in the region have impacted them since the 1950s on, the population has been struggling and has nearly gone extinct at least 3 different times. So I feel like I have kind of a moral obligation that we should also do what we can to try and bring them back. There's lots of other fish in the region that are going to be facing some of the same challenges that the Devil's Hole pupfish does. It's really the canary in the coal mines.
Why are the pupfish important? One, humans develop a lot of our medications from extreme environments. And so we are learning how this vertebrate species lives in warm, low oxygen water. And we still don't know everything about it.
And so these are things that we still have a lot to learn from the fish and from the ecosystem. And if we let it go extinct, so does our opportunity to learn from the fish.